Welcome to YQ Academy Object-Oriented Programming Java Interview Questions and Answers. 1. Explain what is encapsulation. Encapsulation is one of the fundamental concepts of object-oriented programming. It refers to the bundling of data attributes and methods functions that operate on that data within a single unit, called a class. Encapsulation allows the class to control access to its internal state and behavior, providing a clean interface for interacting with the object. 2. Explain the importance of encapsulation in Java. 1. Data hiding. Encapsulation hides the internal details of how an object works and exposes only the necessary information through well-defined interface. It allows the object to maintain its state privately and prevents external code from directly accessing or modifying the internal data. 2. Data protection. By encapsulating data within a class, you can define access modifiers such as private, protected, and public to control the visibility and accessibility of the data. This protects the data from being unintentionally modified by external code, ensuring data integrity and preventing unauthorized access. 3. Code organization. Encapsulation helps in organizing code by grouping related data and methods together within a class. This improves code readability, understandability, and maintainability. Changes to the internal implementation of a class can be made without affecting other parts of the code that use the class. 4. Code reusability. Encapsulation promotes code reusability by providing a well-defined interface for interacting with an object. Other parts of the code can use the object's public methods without needing to know the internal details of how those methods are implemented. This allows for modular programming and reduces code duplication. 3. What is inheritance? Inheritance is a fundamental concept in object-oriented programming that allows a class to inherit the properties and behaviors, methods, and fields of another class. It enables code reuse and establishes a hierarchical relationship between classes. Inheritance is based on the principle of ISA relationship. It allows you to create a new class called a derived class or subclass that inherits the characteristics of an existing class called a base class or superclass. The derived class inherits all the accessible members, methods, and fields of the superclass and can add its own unique members or override the inherited members. 4. Explain the importance of inheritance in Java. 1. Code reusability. Inheritance promotes code reuse by allowing the derived class to inherit the existing functionality of the superclass. Instead of writing the same code multiple times, you can define common behavior in a base class and reuse it in multiple derived classes. 2. Hierarchical structure. Inheritance establishes a hierarchical structure among classes, where classes are organized in a parent-child relationship. This hierarchy allows for better organization, categorization, and management of related classes. 3. Method overriding. Inheritance enables method overriding, which allows the derived class to provide its own implementation of a method inherited from the superclass. This allows for customization and specialization of behavior in the derived class. 4. Polymorphism. Inheritance is closely tied to polymorphism, which is the ability of an object to take on different forms. Polymorphism allows objects of different classes, but related through inheritance, to be treated as objects of a common superclass. This promotes flexibility and extensibility in code design. 5. What is polymorphism in Java? Polymorphism is a fundamental concept in object-oriented programming that allows objects of different classes to be treated as objects of a common superclass. It enables you to write code that can work with objects of various types, providing flexibility and extensibility. In Java, polymorphism is achieved through method overriding and method overloading. 1. Method overriding. Method overriding occurs when a subclass provides its own implementation of a method that is already defined in its superclass. The overridden method in the subclass has the same name, return type, and parameters as the method in the superclass. When an object of the subclass is used to invoke the overridden method, the subclass implementation is executed instead of the superclass implementation. This allows for specialization and customization of behavior in the subclasses while still maintaining a common interface defined by the superclass. 2. Method overloading. Method overloading involves defining multiple methods in a class with the same name but different parameters. The methods can have different numbers of parameters, different types of parameters, or both. When a method is called, the Java compiler determines the appropriate method to invoke based on the number, types, and order of the arguments passed. Method overloading provides a way to define multiple behaviors for a method based on the types or number of arguments, allowing for flexibility and convenience in method invocation. 6. Explain the importance of polymorphism in Java. 1. Code flexibility. Polymorphism allows you to write code that can operate on objects of different types, making it more flexible and adaptable. This simplifies code design and promotes reusability. 2. Code extensibility. Polymorphism enables the addition of new classes and behaviors without modifying existing code. New classes can be derived from existing classes, and their objects can be seamlessly used in place of objects of the superclass. 3. Interface standardization. Polymorphism provides a way to define a common interface or contract through the superclass. Objects of different subclasses can be treated uniformly based on the common methods defined in the superclass. This simplifies code maintenance and promotes modular design. 4. Runtime determination. Polymorphism allows the selection of the appropriate method implementation at runtime based on the actual type of the object being referenced, rather than the static type of the reference variable. This enables dynamic dispatch and runtime polymorphic behavior. This is the end of our Java interview questions. We hope you enjoyed learning with YQ Academy. Until next time, goodbye.